Hello guys, welcome to the channel. In this video, we are going to talk about data structures. Here we have some definitions. Algorithm. What is algorithm? Algorithm is a step-by-step solution of a given problem. If we have a problem given, then we write some step-by-step solution. That is algorithm. Pseudocode. What is pseudocode? Pseudocode is C like a structure for describing the data structure. It is simpler version of programming code in plain English which uses short phrases to write the code for a program. And finally, data structure. What is a data structure? A way of organizing the data in a program so that it can be accessed efficiently. And some of data structures are linked list, stack, queue, tree, etc. And we have program. What is the program? An implementation of algorithm in some programming language. We use some programming language and write some code by using our algorithm, that is our program. Okay, we have to talk about uh, data structure in this video. So let me tell you more about what is data structure. What is data structure? Here we have a data structure. Data structure is made of by two words, data and structure. What is data? Data is raw facts about anything, and a structure. What is a structure? We are structuring our data in a way so that we can access that data efficiently. Okay, efficiently. What is efficiently and what is the access? First of all, structuring of our I will tell you structuring of our data so that we can access. What is access? What do you understand about access? Access means if we talk about some variable or in our program or anything, uh, we can read it, we can write, we can execute. There are three types of access in Unix: read, write, and execute. If we have any file, we can read that file, we can write it file, we can write into that file, and we can execute that file. Okay, if that particular file is executable, we can execute it. Okay, this is the access. And what is less effort? Less effort means what is efficiently? Efficient means we have to we have less effort, we made less effort. What is effort? Effort means we talk about time. Time and time is very precious. It is also precious in our programs. It is very important. And time and space. Okay, we have to use less space and less time. That is called efficient. Okay, if we use very less space and less time, that is called efficient code. In our code, we use less space and less time, that is called efficient code, and less effort. We can perform certain operation in less effort. Okay, hope you understand the effort, the word effort, and efficient and access. Okay, data structure is the first step in program design. One must think of data structure first and then design the program around it. As we first think about data structure according to our problem. We have some constraint given in our problem. According to that constraint, we must choose some data structure. Okay, if we have to linear data storage, we can choose arrays. Otherwise, if we have to store in tree like structure, we use tree or graphs. Okay, in non-linear fashions. Okay, basically data structures are the structuring, means uh, we can access our data efficiently, so that we can access it, we can read it, write it, execute it, or delete it. Okay, what is analysis of data structure? I'm not going to deeper into the analysis of data structure. I'm just giving you the basic idea so that you can understand the analysis of data structure and you can do it on your own. Performance analysis is typically carried out on per operation basis. Okay, performance is stated in terms of big O notation. We use only big O notation. I'm not giving you the understanding of amortized analysis uh, or other things. I will just use big O notation. Okay, big O1. What is big O1 means? Constant time access. Okay, and what is big O(n)? Big O(n) means linear access in terms of number of elements in the data structure. Means if we have n elements and we have to access each elements one by one, we have big O of n time n steps to access that. Okay, let me show you here. You can see here we have an integer array of size n. Array is also a data structure, and if we have to modify that data structure, that array, elements of that array, if we have to modify each elements of the array, first let me tell you, if we modify only one element of array, this is fifth element, if we have to modify fifth element of the array, it is only constant time access. It is only constant time access. It is only one. It is only one step. Okay, this process is only one step process. Okay, but if we have to modify all the n elements one by one, it will be total 1 plus 1 plus 1 plus 1, so on n, means n into 1 means big O of n. Here our loop, we are iterating over the array, and by using for loop, and we move from 0 to n minus 1, total n times we are performing this is step 1. This is big O of 1 step, and we are performing this operation n times, means this is big O of n step operation, total of big O of n. Okay, here we have some commonly used functions and notations. We have big O of x, it is same as big O of n. All the function in the form of k into x. If we have, in the previous example, we had 1 plus 1 plus 1 plus 1, means we had n into 1. We had here you can see this is big O of 1 operation and we are performing it n times, means here value of k is n and value of x is 1, that is total big O of n. Okay, here big O of x means where k is a constant and x is a variable. Okay, if we have this type of operation, means we perform we have this linear equation x square plus 5x plus 10. In this case we will use higher order term, means the complexity of this uh, will be big O of x square, means we perform certain operation big O of x square times. Okay, what is floor? Floor is the greatest integer less than or equal to x. What is ceil? Ceil of x means smallest integer greater than or equal to x. Means floor you can consider about ceiling fan and floor. Floor means uh, if we have 4.5, if we have x equals to 4.5, the floor value floor of x will be 4, means it is less than or equal to x. It will not be greater than 4.5. You can consider the floor of a room. Floor will be lower value and ceil will be, you can understand it like a ceiling fan. Ceiling fan will be on the top of the floor. Okay, on the ceil. Okay, this is smallest integer greater than or equal to x, means we have 4.5 and ceil will be 5. If we perform ceil of x, that will be 5. Ceil will be 5 and 4 will be 4. Floor of x will be floor, means we are considering integer values. Okay, we are taking, for taking integer values we use full floor and ceil operations. X raised to the power k, that will be x multiplied k times. If we multiply x by k times, it will be x raised to the power k. Lg of x means log to the base 2 of x. Log of x, natural logarithm base e of x. Guys, these are used in the analysis of our data structure. That's why I'm telling you. Okay, here we have an example of linear search. We have these data sets 1, 10, 15, 20, 16, 20, 30, 33, 36. This is sorted. All the elements are in increasing order. No, not in increasing order. Okay, this is unsorted array. Okay, and we have first of all we have a key 1 that is equals to 1. Okay, we have to find a key in this data set. Okay, and we have key 2 that is 16, and we have key 3 that is 36. We have to find these three keys. First of all, we find key 1. For this operation, what will we do? What we will do? We will iterate over the array. Simply we will iterate over the array. We will do linear search. Okay, we will check, we will compare each element of the array and see where is the where is our key. If particular element is equals to that key is found, the the address of that element will be returned. Okay, here we have key 1. Key 1 is equals to 1. We will see here at first position, at 0th position, this is the first element at 0th position. It is found, and it is found for it is found in only one step. Okay, it is the first element, that's why it is found in the first operation. Okay, we don't have to put more effort for this operation. Okay, so this is constant time operation. The complexity will be big O of 1, and this is called best case. Best case means we have very less effort. And what is average case? Average case means we have to do more effort than the best case. Okay, and what is the worst case? Worst case means we have to do maximum effort ever possible for that data structure. That is worst case. Here if we find key 2 will be find 1 0 1 2 3 4. Our loop will perform the operation, searching operation, comparison operation will be performed 5 times. Okay, first it compare with 1, after that 10, after that 15, after that 20, after that 16. When 60 equals to the key 2, our element is found and the index will be returned. Okay, means it is at 4th index. Then what will be the complexity? Complexity will be big O of n by 2. Okay, this is our average case complexity. And what is the worst case complexity? If we find key 3 that is 36, we will compare with all these elements, and 36 is not there. 36 is at the end of the array. This is last element, and we will perform, we have total 3 6 and 9, we have total 9 elements. We will perform the comparison operation 9 times we will it will be performed, means big O of n, that is of worst case. This is how we do the analysis of best case, average case, and worst case. And what is the space complexity? Space complexity is big O of n, means we are storing n elements into the array. We are using a space of n elements. Okay, that's why we have a space complexity of big O n. I'm not going deeper into the analysis. I'm not going to do maths for the analysis, amortized analysis, and many more things. I'm just simply giving you the idea how you count the steps on your own in your code. Okay, next we have types of data structure. What are types of data structure? Data structure are of two types: linear data structure and non-linear data structure. Linear, first of all, linear data structure have two types: static and dynamic. Static means arrays. Arrays are static in nature. We have fixed size. Arrays have fixed size. And dynamic, when we talk about dynamic linear data structure, that is of linked list, stack, and queue. It grows at the runtime. Okay, it doesn't have any fixed size. These data structures are not have fixed size. Okay, here we have non-linear data structure. Non-linear data structures are tree and graphs. Okay, so hope you understand the basic concept of data structures. If you understand the concept, like my video, share with your friends, and subscribe the channel Programming Influencer. Okay, thank you guys. Thanks for watching. Happy coding.